In this presentation in the Grade 10 CAPS Mathematics video series, the focus will be on probability. 2 to the power 2 or 4 events in this experiment, since an event is simply the subset of a sample space, and the events in this experiment are therefore the empty set, the set containing the element H, the set containing the element T, and the set containing both the elements. These 4 events can be described in a verbal way. Following a card from a standard pack of cards in an experiment. So in experiment 4, a card is drawn from a standard deck of playing cards. Those of you that don't know playing cards, we have 13 clubs, 13 spades, 13 hearts, and 13 diamonds. So for this experiment, the sample space consists of 52 outcomes, because there's 52 different cards. And there will be 2 to the power 52 events. Quite a large number. I leave this for you as a challenge and an exercise to read this. Give a name to this. Don't read 4503, 599. Find a proper name for this number. Now if we look at the events, we say there's 2 to the power 52 events. It's impossible, really. Not impossible, but it will take a very long time to list and describe all these events. Just to show you one example, for instance, the event of drawing a face card. In other words, getting one of these 12 cards. Then this event can be illustrated in this way. So in other words, you either get a jack, a queen, or a king. So this will be 12 cards out of the 52. This is just one of the specific events. Let us look at theoretical probability. Now probability is a real number in the closed interval 0, 1 that describes how likely it is that an event will occur. A probability of 0 means that an event will never occur. So in other words, it's impossible. A probability of 1 means that an event will always occur. So in other words, it's absolutely certain. While a probability of 0.5 or 50% means that an event will occur half the time, or there is a 50-50 chance that it may occur. We define the theoretical probability of an event as the probability of an event is the number of outcomes in an event, which is the cardinal number of the event, divided by the number of outcomes in the sample size, which is the cardinal number of the sample size. Now the probability of the event, which is the empty set, is 0. Think in terms of our examples that we had. If you can give an example where the probability is 0, while the probability for the sample size, not sample size, sample space, right, is 1, and the probability of an event will be smaller or equal to the probability of the sample space, but greater or equal to the probability of the empty set event. So therefore, in terms of numbers, the probability of an event is always smaller or equal to 1, but greater or equal to 0.